Good morning, Algebra 2. Today we are going over Standard 4, Day 4, and this is an extension of systems of equations. And so we wanted you to be exposed to this material, but not necessarily directly assessed on this material. So to recall, the solution to a system of linear equations is an ordered pair that makes all equations in the system true. But now look at the example below, example 1. You'll see that there's 3 equations with 3 variables. There's an x, a y, and a z. So there are 3 equations with 3 variables, an x, a y, and a z. The graph of an equation in 3 variables, all to the first degree, is not a line. Instead, it is a plane. There are still 3 possible solutions to a system of 3 equations with 3 variables. When there's one solution, it looks like this. We've got the 3 planes. They intersect right here at that point. But you'll see that that point is x, y, z. So that isn't an ordered pair because there's not 2 variables. Instead, it's an ordered triple because there are 3 variables. X, y, z. For our second type of solution, we could have infinitely many solutions. That is when our 3 planes intersect in a line, right there. And so there would be infinitely many solutions. Finally, we could have no solution, which means the 3 planes do not have a point in common. Here are 3 examples of what that could look like. So some of the planes could intersect, or they could intersect at more than one point, but the solution has to be where all 3 planes intersect. Okay, so to solve these, sometimes one of our equations we could solve right away. The first one, negative 4x equals 8. We could solve that one by dividing both sides by negative 4 and getting x equals negative 2. Then we take that solution and plug it into one of our other ones, like the 5x plus 2z equals 0. So then we can add 10 to both sides here and get 2z equals 10. So that was a 2z equals 10. So z equals 5. Now for our third variable, we can go to our third equation, and it was 7y plus 3. We now know z is 5 equals 22. So 7y plus 15 equals 22. Subtract 15 from both sides, so 7y equals 7, and y equals 1. So now we can write our ordered triple. Just like in an ordered pair, we write our variables in alphabetical order, so x was negative 2, y was 1, and z was 5. It doesn't matter which one we solved to find first, second, or third. We still write them in alphabetical order. Now to check our solution, we need to check our solution in all 3 equations. So first we'll check equation 1, and that was negative 4. Instead of x, we'll plug in negative 2 equals 8. 8 does equal 8, so it checks in equation 1. We check equation 2. Equation 2 was 5x, so 5 times negative 2, plus 2 times z was 5, equals 0. We get negative 10 plus 10 equals 0. 0 does equal 0, so it checks in our second equation. In our third equation, we have 7y, and y is 1, plus 3z, z is 5, equals 22. So we get 7 plus 15, and 22 does equal 22. So we checked our solution in all 3 equations, and so that is our correct answer. Next, when we look at problem 2, all 3 equations have all 3 variables. So is that going to come back into focus? No. Let's try again. Okay, all 3 equations have all 3 variables in them. See if I do it like this. Force it to focus. No, it's just getting worse. and 6, getting worse. I can see that it starts to focus and then decides to quit. No idea why. Finally, okay, that was a bit of a waste of time. So, in our 3 equations, none of our variables are going to cancel out right away. So we can't solve for any of them yet. So we need to pick 2 equations. And so I think it's always easier to start with equations 1 and 2 and eliminate x from those 2. So our first equation was x plus 2y plus z equals 10. If we want to eliminate x with our second one, we need to multiply that equation by negative 2. So we get negative 2x minus 4y minus 2z equals negative 20. So we took that entire first equation, multiplied it by negative 2. Our second equation is fine the way it is. And so now our x coefficients are opposites, so we can add those 2 equations together. We eliminated the x's, and we get negative 5y plus z equals negative 25. Now we're going to do that same thing again, only we're going to look at equation 2 and 3, but we're still going to eliminate the x variable. So for equation 2 and 3, we're going to multiply our first equation by negative 1. And so that will give us negative 2x plus y minus 3z equals positive 5. And then our third equation, the 2x minus 3y minus 5z equals 27 is fine just the way it is. So now when we add, we are going to eliminate our x's and we'll get negative 2y minus 8z equals 32. Now we've got 2 equations here that both have a y and a z. So I'm going to write them right underneath each other. Negative 2y minus 8z equals 32. So if we eliminate the z's, all we have to do is multiply that first equation by positive 8. So it will now be negative 40y, and then we'll get plus 8z equals negative 200. Now we're looking at these 2 equations. We're going to add them together. Our z's are eliminated, and we get negative 42y equals negative 168. Divide both sides by negative 42, and y equals 4. So we now know one of our variables. Now we'll pick one of these equations, either this one or this one, and plug in our y value. So I'm just going to plug it into the first one we found. So negative 5, instead of y, we're plugging in 4, plus z equals negative 25. So negative 20 plus z equals negative 25. Add 20 to both sides, and z equals negative 5. Now I know z, and I know y. To find x, I'm going to go back up to the very first equation. It was x plus 2y, but now instead of y, I plug in 4. And then plus z, so plus negative 5, equals 10. So x plus 8 minus 5 equals 10, x plus 3 equals 10, and x equals 7. So now I can write my ordered triple, x first, which was a 7, then the y, and then the z. To check it, I need to check it in all 3. So equation 1 would be x is 7, plus 2 times y is 4, plus z is negative 5, equals 10. So that's 7 plus 8 minus 5 equals 10. 10 equals 10, so that checked. Equation 2 is 2 times x, which is 7, minus y, which is 4, plus 3 times z is negative 5 equals negative 5. 14 minus 4 minus 15 equals negative 5. 10 minus 15 is negative 5, so that one also checks. And finally, in equation 3, so that was 2, and then x is 7, minus 3, and y is 4, minus 5, and then z is negative 5 equals, it's running out of room, equals 27. And then this is getting a little blurry again. I'm going to finish this one and then try to focus again. 14 minus 12 plus 25 equals 27. 2 plus 25 is 27. So 27 equals 27. And it checked. So our ordered triple is 7 for negative 5. Next, our last problem is a word problem. It says at the 2004 Summer Olympics in Athens, Greece, the United States won 103 medals. They won 6 more gold medals than bronze and 10 more silver medals than bronze. We need to write and solve a system of 3 linear equations to determine how many of each type of medals they won. So first, we got to pick our variables. I'm going to let x be the number of gold medals, y be the number of silver, and z be the number of bronze medals. Okay, then our first sentence says the United States won 103 medals. That means if we took all of these and added them together, it would equal 103. So that equation would be x plus y plus z equals 103. The next sentence starts out, they won 6 more gold medals than bronze. So the number of gold medals is going to equal the number of bronze medals plus 6. So it'll be x equals, that was the number of gold medals, equals the number of bronze medals, z, plus 6. And then it says they won 10 more silver medals than bronze. So the number of silver medals equals the number of bronze plus 10. So silver medals is y equals bronze, which is z, plus 10. Now I've got my 3 equations, my system of equations, 3 equations, 3 variables. So, since x equals something with a z in it, and y equals something with a z in it, I'm going to plug both of these into the first equation. So I'm going to plug this in for x, and I'm going to plug in this for y. So that means instead of x, I'm writing z plus 6. And then I've got a y, and, oh, whoops, it equals z plus 10, and now plus z equals 103. So z plus 6 plus z plus 10 plus z equals 103. Combine like terms, and 3z plus 16 equals 103. So 3z equals 87, z equals 29. Then for y, it's z plus 10, and so y would equal 29 plus 10, so y equals 39. And then x equals z plus 6, so x equals 29 plus 6, x equals 35. So to answer the question, you could say the Olympians won, so x was our gold medals, so 35 gold medals. Y was our silver, so 39 silver, and 29 bronze. Make sure, since it's a word problem, you write your answer out as a sentence, and then go ahead and work on your skills practice, and let us know if you have any questions.